And we are going to be now doing some awesome problems on isosceles trapezoids, which, remember, a trapezoid is a quadrilateral that contains just one pair of parallel sides. So this one is a quadrilateral and it contains one pair of parallel sides, which makes it a trapezoid. Now, what makes it an isosceles trapezoid is the fact that it has two congruent sides. And remember, there's some nifty properties that are associated with isosceles trapezoids, which I'm going to pull that up right here. Oh, didn't mean to do that. Let's see here. Alright, so here are our properties for an isosceles trapezoid, which that is going to help us as we solve. Okay, which I'll make it a little bigger. Alright, so again, an isosceles trapezoid is a trapezoid whose legs are congruent. Holy hot dog. So the legs are congruent. And the properties, each pair of base angles are congruent. So the two angles that share a common base, which are the parallel sides, will be congruent. So like B and C are congruent, as well as A and D. And also, our diagonals are also going to be congruent. So those are all some nifty things that we can use to help us solve. And also keep in mind we have parallel lines cut by one transversal here and another transversal here. So that means some parallel line properties might pop up as well. Okay, so the first one says to find the measure of angle y. So this is our end goal. That's our goal right here. We want to find what angle y is. Alright, so we're given that W is equal to 117. Now, which angle is congruent to angle W based on the properties we just talked about? Holy hot dog, you guys are so smart. It is Z. Okay, so these two are congruent because they're base angles. So angle W is congruent to angle Z. So if angle W and angle Z are congruent, what does that mean angle Z is going to be? You guys are too cool for school. Angle Z would also be 117 degrees. Okay, so we're kind of working our way to angle Y. So from here, do you see anything that might help us find the measure of angle Y? Well, if we have some parallel lines here, can we use these using maybe Z and Y or Y and another angle to help me find what the measure of angle Y could be? Well, let's see what happens. When I trace over angle Z and angle Y, what kind of letter do they make? They do make that U or C kind of shape or an N shape. And this one's kind of like a backwards C. Alright, and do you remember what those angles are called? They are same side interior angles. And how do same side interior angles relate? They are, in fact, supplementary. You guys are so smart. Okay, and so that means these two are supplementary, which means they add up to be 180. And that's going to help me to solve for y. So the measure of angle Z plus the measure of angle Y should add up to be 180. I'm going to hide this for a moment. Go away. Bam. All right, let's keep going. Alright, so I'm going to fill in the values for the angles that we currently know, which I know that angle Z is 117 degrees, holy hot dog, plus the measure of angle Y equals 180. Alright, let's solve this thing for Y, and then guess what, you guys, will be done. That'll be it. So how do we move 117 to the other side? We do, in fact, subtract the 117. So I'm going to subtract that thing on both sides of my equation, which 117 minus 117 cancels and turns to 0. 180 minus 117, well, 180 minus 100 is 80, and 80 minus 17 will give me 63. So guess what, you guys? The measure of angle Y is 63 degrees. And guess what? Bam! We are currently done with that problem. Holy hot dog, you guys.